We're back. Our next discussion is going to be on the use of lasers in geography. Now, lasers are a commonly used tool for many types of applications, but also in geography as well. Now, lasers, it's an acronym. Something means light amplified by stimulative emission of radiation. SER. Actually, these were first developed in the late 1950s, and since then they've had explosive number of applications, and really just about all walks of life. It's very simple, just have a laser crystal. You have your light, bright light shining off of it, mirror behind it, mirror in front of it, lens, and coherent beam of light. Basically. But what kind of power it has behind it and what kind of crystal it does to make that laser, those are very different depending on the uses. Most lasers we see in everyday life, they're very low power. And even the color of a laser, that is determined by the kind of crystal it uses. And of course, for most lasers, they really don't need a lot of power. We think of lasers as science fiction uses, the use of weapons and weaponry, Star Wars, Star Trek, that kind of thing. And there are some military applications. Recently, as they learn how to control and amplify the use of the power behind the laser. But again, it's a very versatile tool. Lasers can be used in cutting. Like jewelry, metals. It can be used Navy started to use these as anti-missiles, part of anti-missile systems. But in geography, you've got a lot of different uses for these as well. Lasers, they are used for detection. They can be used for metering, scanning. Of course, a lot of this is going to work with geographic systems. Of course, where can you use them, and how are these distributed? What kind of uses are you looking for? What are you trying to do with them? And of course, a lot of lasers that's being used with GPS systems, because sometimes you need to be able to very closely zero in on your location, be able to use the laser, even just for simple sensing and scanning purposes. Lasers can be used for map making, for measuring topography. It can be used for where you have your ArcGIS systems coming in, simple map making skills. And of course, with the target designation as military use, that also will use GPS systems. Night vision goggles can use forms of lasers using infrared light. This handy little chart here. Infrared, of course, the far end past here. This is the visible spectrum. This is what human beings can see. And up here, past violet is the ultraviolet range, and then the more powerful, shorter wavelengths, ultraviolet, gamma rays, then X-rays, and infrared back to here, back to back on over. These are the longer waves. These are the shorter waves. And these waves are typically measured in something called angstroms or nanometers. Example here at the green end of it, typically find something about 543 nanometers. Violet end of it, again, the most purplest end of the human beings typically see, 400 nanometers. And the furthest red end, 750 nanometers, again, the shorter, longer wavelengths. Now with this, you can see all sorts of different kinds of applications you can use with lasers. Of course, with anything kind of tool, it's the right tool for the right job. Certain proper type of crystal being needed for laser uses and so forth. The more high energy ones are the ones used for military applications and so forth. Ultraviolet, gamma rays, X-rays, beyond that. Laser rangefinders, what's called LiDAR. In a lot of military applications, but a lot of civilian applications as well. Measure time of flight by sending an infrared laser pulse at 905 and 1500 nanometers toward an object and measuring the time it takes for the pulse to be reflected off the target and return. That's also the same principle used with some types of laser scanners that use for police officers use to see if you're speeding or not. Lasers are very precise, therefore kind of hard to beat in court. But another use of it is, of course, measuring the speed of a fastball, the pitch in baseball. So they know the difference between an 80 mile an hour a lob versus a 100 mile an hour fastball. But again, a lot of different, many applications. Some more common uses for lasers include CDs and DVDs. That's actually a small, low-power laser that is scanning your CDs and DVDs to see what information is recorded on it. It's translated into the images we see or the songs we hear. It's used very commonly in medical diagnostics now. High energy ones that are used for things like even used as surgeries, laser scalpels. Lasers are often used for eye surgery because of the precision of them. Lasers are sometimes used in other types of surgery more and more. Learning how to use, so they learn how to use them. And of course, go to a grocery store, they scan your items, scan those UPC codes. That's a laser using it. Low power laser, but it's a laser nonetheless. So remember, lasers aren't just for blasting spaceships out of the stars. It's also very common, very peaceful applications as well. And another source of how to use lasers is in agriculture. Laser control systems are being used in farms at experimental level, increasing more and more for pest control. Yes, they can use lasers to zap little insects and roosting birds. Laser net, like what they might use with an alarm system at your house. Yeah, that's also lasers they're using. That can be used to set up some kind of disruptive system to scare away birds or insects is using set off the system to use maybe high frequency pulses because the lasers detected something's entered that area. But some of these pest control networks using lasers, they can cover 3,000 acres at a time. Dimensional scanning, that can be used in the lumber industry. Certain structured light lasers designed specifically for dimensional scanning of raw logs. These lasers can create volumetric data for the logs that are unloaded from trucks. That is helping keep up with inventory and know what logs are where and how to distribute them. Again, a lot of geography going on from there. And additionally, lasers can then be used to grade processed lumber or identify defects like bowing or cracking. So lasers are very good at scanning and detecting. They look for lasers can be programmed to look for specific patterns. That is how something's reflecting off of the beam. Is it within what they're looking for, or within the range of what they're looking for, or is it a little different? Laser technology can be used for sorting to enable efficient quality control and fruit processing. Target parameters such as dimensions, color, size can be used to automatically determine structural color defects or contaminants are present, therefore increasing the efficiency of agriculture, fruit processing, and food distribution. And even for lasers to be used for crop sensing applications, help measure the health of an individual plant or an entire field. That is, again, low-level lasers can be used to look for certain defects, look for certain patterns. Laser scans it. The computer is programming the program to scan the reflection from that laser, can see what is there. Can measure plant health techniques such as a hyperspectral imaging. Fertilizer placement may be optimized to reduce waste and improve yield. And at the individual plant level, lasers can be measured the ripeness of a fruit or health of a crop. So all things that require different types of lasers. And of course, lasers, they're commonly used now in fiber optics as well. Fiber optic cables, they basically shoot laser beams through them because lasers can carry a lot of information in them, those going back and forth. But again, these are low energy lasers. So they're not going to be burning through the fiber optic cables or anything like that. But we can see the different types of lasers here being used on this chart. Again, this is the visible spectrum, that is the area that human eyes have evolved to be able to see. But with different types of lasers, again, you use different types of crystals and so forth. For example, xenon chloride here, scanning at a wavelength of 308 nanometers. Ultraviolet end of it. Hydrogen laser, moving in here towards 100 nanometers at the extreme end of the ultraviolet end. We got near infrared and the far infrared. For example, lead salt we use to scan at the mid infrared from this range here. And these are what are commonly used with commercial lasers. Just need low energy lasers just simply to see what works. Interestingly enough, laser scanners, if you scan them into a light detector, you can combine the colors. Two lasers shining at the same spot, their colors can combine to form a new color, but say yellow and blue will make green, but the yellow laser and a blue laser will still scan as a yellow laser and a blue laser, not at the green spectrum. But detector ranges. The ultraviolet range here, selenium and nitrogen, cadmium, sulfur here towards the more visible range. And of course, a lot of that on the infrared scale. Because you got to remember, scanning and detection, that's more on the lower end of it. You don't need a lot of power for that. So generally from the visible spectrum on down into the infrared spectrum. And of course, optical materials used with such things as fiber optics and so forth, communications, and a lot of that using lower power lasers. Quartz crystals from the infrared, from the visible range on into the mid-infrared range, far infrared range. Magnesium oxide from here to here, used as optical materials and so forth. Silicon can be used for lasers with the infrared range. But again, all these are going to have different uses, and you use certain lasers for certain uses, certain tools. Again, whether it's advanced lasers or it's stone tools, it's still basically the principle, the right tool for the right job, no matter how advanced or how primitive the technology might be. And lasers, because they are amplified, these tiny little light beams, everything from laser pointers to lasers in agriculture or mapping or whatever else, they're very precise instruments, very focused, very narrow beams, and all have very different uses. So that is a brief overview of lasers and geography.